Today, our presentation is about facial expression recognition using aggregated handcrafted descriptors-based appearance method. If we come to the introduction, there have been quite a few studies on facial expression recognition over the years, and it's still a challenging subject due to the significant interclass variability. Facial expression recognition has long been an important and challenging topic in computer vision area. The goal of most researchers is to develop a system that can automatically recognize various facial expression recognitions in image. The traditional facial expression recognition method made the most significant contribution by focusing on the expression of frontal faces. If you look to the facial expression, there are two categories of different methods for solving a facial expression problem. A set of expression that classified by action units, which these are small but identifiable muscle action. This one, but the second one is very various. In the second method, feature extraction method are typically utilized based on machine learning technique. Few extracted features are utilized to represent an expressive image and trained a classifier for facial expression recognition in facial expression recognition. Then facial expression recognition systems that have been previously been studied and are referred to as related works. The external pattern used to represent the appearance feature is extracted from intensities of facial image. Here there are some previous works. In reference number 7 may be suitable for capturing a range of different images, each of different scale and orientations. It has also been determined that the local binary pattern has benefit when it comes to feature expression, feature extraction in facial expression recognition. In the reference number 10, propose the method that statistically extract robust feature representation for different classes for facial expression. And the new feature representation was created by using the compressive sensing method and statistical analysis of extracted compressed facial signal. And in the reference number 4, introduced and improved a method for facial expression recognition. They used coverlet transform with graph signal processing are exploited to build a model that can recognize facial expression. In their study, feature vectors dimensionally has been reduced and recognizing facial expression has been extremely ameliorated or improved. If we come to the proposed work, if we look at the diagram, we have this study describes a way to categorize facial expression. The primary goal of the research is to improve the accuracy with which different types of facial expression are classified. If we look at the diagram, we have the image and we go through the face detection. First, we do the face detection. For face detection, we consider this stage as the pre-processing of input image because this pre-processing is required, which is face detection before extracting features. So in this method, our method of face detection, we have used a DILB library, which is known as its fast processing speed for detection phase. So after that, we go through for feature extraction. We extracted the feature based on LBP and hog features. In LBP, we extract the LBP, but for hog, we extract hog and diagonal hog. After that, we aggregated or we combined all features and we fed to the classifiers for classifications to classify based on angry, This goes and set few natural surprise. So when we came to the experimental results for our proposed method, we have we have discussed that we have discussed that the performance of the proposed model on the JAV dataset, we used 133 images for training and 23 images for validation and 80 images for testing. So the accuracy of classification is the metrics that is used to assess the correctness of the proposed study. We evaluate each feature independently and compare the accuracy of LBP, hog, and diagonal hog have been computed for emotion recognition. If you look at the table, we have different emotion and we have different features, and for each features we have obtained different uh, uh, accuracy. Overall accuracy for hog feature we obtain 93.44, and for diagonal hog we obtain 94.48, and for LBP we obtained 86.89. After that, combine these features, we obtain the accuracy 95.70. If we look at the table, this table provides a comparison between several state of art studies with our proposed study. To see the ability of recognition of each descriptor, we calculate the accuracy of recognition of each one with the proposed method. If we look at the table for hog, diagonal hog LBP, we have obtained the higher accuracy with diagonal hog. But when we compare with the previous works, reference number 18 obtained 94.37, number 17 obtained 95.31, and 11 obtained 19.5. When we combine these features and we calculate the accuracy, we have obtained 95.17, which is considered as a acceptable accuracy, performance accuracy for facial expression. So when we come to the conclusion, the main purpose of the paper is to propose a method for facial expression recognition with achieving high accuracy. Different texture descriptors including LBP and hog were exploited in this study, but in hog we have used hog feature and diagonal hog feature. A new method was proposed with aggregated descriptors of hog, LBP, hog, and diagonal hog features. To evaluate the performance of the proposed method, an online available dataset named JAP has been used. The experimental results show that our proposed method has ability to recognize facial expression successfully. Thank you so much.